Okay, guys, so today we're going to be solving systems of equations using substitution. Yesterday we solved systems of equations by graphing, and we were looking for the point of intersection. The point of intersection is the solution. So if there is no intersection, then there is no solution. So yesterday we learned one method. Today we're going to learn a second method. So we're going to solve systems of equations by substitution. So the first thing that you need to know is that when substituting, at least one equation needs to be solved for a variable. So I'm going to go ahead and write that down. So when substituting, at least one equation needs to be solved for a variable. Okay, so what exactly does that mean? That means, for example, one of the equations needs to be in the form of x equals, where x is by itself, or it needs to be in the form of y equals, where y is by itself. So at least one of the equations needs to be solved for a variable. If you don't have a system where at least one equation is solved for a variable, then you're going to need to solve it. You're going to have to pick one. Either pick x and solve it for x, or pick y and solve it for y. But at least one equation needs to be solved for a variable in order to use substitution. So let's take a look at an example. So I want to solve this system using substitution. So let's say I have y equals negative x plus 3. So first thing I'm thinking as I'm writing that equation is, yes, that is solved for y. So that equation is solved for a variable. The y is by itself. So I'm good to go. My second equation in my system is going to be 3 times y plus 5x equals negative 1. So I'm going to solve this system using substitution. So I know from my first equation that y equals a negative x plus 3. This is what y is equal to. So that means wherever I see a y, I can replace it with negative x plus 3. Well, right here in my second equation, I see a y. So I am going to take negative x plus 3, because that's what y equals, and I'm going to replace y in the second equation with negative x plus 3. Or I'm going to substitute. I'm going to substitute negative x plus 3 in place of y. So when I do that, I will have 3. And then make sure when you substitute, guys, that you use parentheses. So 3 times the negative x plus 3, and then plus 5x equals a negative 1. So what's happened here is we've gone from 2 separate equations that have 2 separate variables. For example, this first equation has x's and y's, and so does the second equation. And what we've done by substituting is we've gone from 2 separate equations with 2 different variables to one equation that has only one variable in it. This is all x's. And then at this point, we're going to solve this just like we've solved any other equation. So we're going to actually solve this for x, because that is the variable in question. So to do that, we need to get rid of parentheses. We can get rid of parentheses using the distributive property. So I'm going to distribute that 3 all the way through. So I'm going to have a negative 3x plus 9, and then I'm going to bring everything else down. Plus 5x equals negative 1. Next step is to combine like terms. So I have a negative 3x and a positive 5x. Those can be combined to give me 2x. And then I'll bring everything else down. So 2x plus 9 equals negative 1. And now we're down to a two-stepper. So we need to undo addition or subtraction first. So I'll go ahead and subtract 9 from both sides. And that will get me to 2 times x equals a negative 10. And then my final step to get x alone is going to be to divide by 2. So I'm dividing by 2. So we know that x equals a negative 5. That's what x equals. Now, it's important to remember that a solution to a system is a point of intersection, a point, an ordered pair. And an ordered pair has an x, but it also has a y. So we are not done. We have to find the y value. All right, so in order to find the y value, so to find y, all right, we need to go back to one of our 2 original equations and pick one. Pick one of them. And then what we're going to do is replace x with negative 5 and do the math. Now, you can choose either one of these, but if I were you, I would choose the top equation. And the reason that I would choose the top equation is because it is solved for y, and that is what we are trying to find. So I'm going to take that equation. I'm going to take my y equals negative x plus 3, and I am going to take my value of x, which we just found, x equals negative 5. And I'm going to use these 2 things right here. I'm going to use these 2 things to find y. So I am going to plug negative 5 back in here for x. So I'm going to have y equals a negative, but then I am going to also substitute in a negative. So double negative right there makes a positive. And then I'm going to add 3. So what I really have here is y equals 5 plus 3 and y equals 8. So my solution is the point negative 5, positive 8, because points have x's and y's. So there is my answer. All right, let's try another one, okay? Let's say, example number 2, that we have 2 times x minus y equals 23. And as I write that, I'm thinking to myself, okay, that's no bueno, because at least one of my equations needs to be solved for a variable. And that is not solved for x. That is not solved for y. So I'm already contemplating, am I going to have to solve this for either x or y? But let's see what the next equation looks like. The second equation is x minus 9 equals a negative 1. Okay. Second equation is also not solved for a variable, but this second equation is way easier, meaning less steps to solve for x than this top equation. So I'm going to take this bottom equation and I am going to solve this for x. So I'm going to solve for x. The bottom equation, I'm going to solve for x, but the top equation is going to stay the same. It's going to stay the same. I'm not going to touch it. I'm leaving it alone, all right? So I'm actually going to just rewrite that over here. So 2x minus y equals 23. So the top equation is staying the same. Oh, sorry, it's a little blurry, guys. There we go. But the bottom equation, we're going to solve for x. So I'm going to get x by itself, I just need to add 9 to both sides. I'm going to add 9 to both sides. So I'm going to get x equals a negative 1 plus 9. So x equals a negative 1 plus 9, which is 8. So x equals 8. And now I can substitute exactly like I did in the last problem. So I know that x equals 8. So that means wherever I see an x, I can substitute 8 in its place. So I see an x right here. I see an x right here. So I am going to replace this x with 8. So I'm going to take 8, because that's what x equals, and I'm going to substitute it in there. So this will be 2. And remember, when we substitute, we always use parentheses. So 2 times 8 minus y equals 23. And now we're going to need to solve this for y. We got to get y by itself. So 2 times 8 is 16 minus y equals 23. So I'll go ahead and subtract 16 on both sides. And I'm going to get negative y equals 7. And remember, there is an imaginary 1 right here. So this is really negative 1 times y. So I actually need to divide by negative 1, divide by negative 1. So I get y equals a negative 7. And again, you are only halfway done. All right, right now your answer looks like this. We know that y is negative 7, but we do not know what x is. This is a question mark. So we have to find x. So just like we did in the last problem, we're going to go back to one of our 2 examples up here, and we're going to plug negative 7 in for x and do the math. But actually, I don't even need to do that, because what does x equal? Duh. Let's work smarter, not harder. X equals 8. So our x value is actually 8. So the solution to our system is 8, negative 7. So if we were to graph these 2 lines, they would intersect at the point 8, negative 7. I think that is pretty much about it. So there is homework tonight in Big Ideas. Whoop. So sorry, it's definitely blurry when I hold it a certain way. But I'm going to post the video, so obviously you can watch it and rewatch it. Don't forget that